Alright guys, so this video might be a little longer because you're not going to have a video tomorrow. Tomorrow you're going to completely work on an assignment. So if you are on hybrid and you're at home today, tomorrow in class you're working on an assignment. So this video is going to be a little long. There is no foldable, that's why nothing is posted at the bottom of this video. Everything that we're putting in our notebook today comes from your book. So, to get started, you need to open your notebook, page 16, and we're going to label page 16, Reasoning and Proof, and I believe it's 1.4, but I'm going to check. Yes, 1.4, Reasoning and Proof. I don't know if I've said it in a video before, but just so you know, geometry is kind of all over the place in the beginning. Starting next week, it will not be all over the place, okay? It's going to be like we're going to do a certain thing for a while. But right now it is. Today's lesson is an introduction to reasoning, proof, that kind of thing. Eventually we're going to do a lot of proofs. And I know you're going, proofs? Yeah, it's going to be all right. We're going to figure it out, learn it as we go. So you need, from your textbook, to tear out page 46. So in case you missed that, page 46. I'll put that right under here so you can see what page number I said. I'll show you what's cut out in a minute. Page 46. And page 47. Yes, your page 47 has a big hole in it from the other day. That's okay. So 46 and 47. Have those torn out so that we can cut things out. Got it? 46, 47. I'm moving now. Okay. From page 46, do not tear up or crumble up your pages until the very end of this video, because you don't want to lose something in case you need it. By the way, later when we get to proof, you'll see what I mean by proof. Actually taking and proving that things work or that things are true or whatever, you will have to come back to page 16 all the time. I will tell you, oh, that property, it's on page 16, okay? That's something that you're going to have to know and do. All right, I need you to cut out from page 46 this. From the words a conditional statement to properties of equality, okay? I'm going to start gluing it in right now, so if you need a minute, pause it. I'm going to glue it. Okay. So glue that in on page 16. Now we're going to talk about it. A conditional statement, already highlighted for you, is a statement that can be written in the form if P, then Q. Where P is the hypothesis, this is important, P is the hypothesis, and Q is the conclusion. For example, in the conditional statement, if 3x minus 5 equals 13, then x equals 6. The hypothesis is 3x minus 5 equals 13, and the conclusion is x equals 6. Most of the properties of equality can be written as conditional statements. Here they are below. You have used a lot of these properties. The problem is you've never used them to talk about proving that things are true, okay? The addition property of equality says that if you add something, if you have something that's equal to each other, if you add the same thing to it on both sides, it's equal. Well, you're used to solving equations that way. If you have x minus 6 equals 12, you know that if you have an equal sign, if you move something over to the other side, if you do it to both sides, it's still equal. Same with subtraction, multiplication, division. Reflexive property is one of those like, well, duh, but you have to list properties later when you're proving things. The reflexive property literally says something is equal to itself. I'm not kidding, that's a property. All right. Symmetric property says that if A equals B, then you can reverse it and say B equals A. Transitive property says if A equals B and B equals C, then A equals C. Okay? And you're going, okay. Here's how I like to think about that one. You know the book when you were a kid, if you give a mouse a cookie, and then if you give a mouse a cookie, he's going to want milk, and then he's going to want this, and then he's going to want that. Well, if you start out with if you give a mouse a cookie, at the very end, it talks about what he's going to want. I almost could just let me go pull that book out. But the point is if these two are equal and these two are equal, then obviously the first and the last need to be equal. Okay. Substitution property of equality. You've been using that one a lot. You literally, if A equals B, then you can substitute it in an expression. So like if you've had 3x plus 5, and you say, okay, x equals 2, I'm going to substitute that in. That's the substitution property of equality. The new ones are these three right here. So put a little star by them. Those are new. You do have to know them. Properties will be on a quiz. Okay? Not this Friday's quiz, but on one quiz. I don't think on this Friday's. I should probably check before I say that to you. All right, so here's what you need to know from here. Now I want you to take page 47. Again, remember, you're not cutting, you're not throwing anything away until we're done with this video. This comes from 47, and you're gluing it right there to the bottom of page 16. Move my stuff so you can see it. Glue that on the bottom of 16. It came from 47. If you need a minute to get that cut out, pause the video. Okay, we are going to use deductive reasoning, which we'll talk about what that means in a minute, to solve the equations here. The first one's done for us. It wants to give an example of what's going on and the reason behind it. So these over here are the reasons we were able to do what's going on over here. So we've got some reasons that are going on over here. Okay? So if we're solving this equation, the first thing we do to solve an equation, we're going to move this 17 over. And 9 minus 17 is 8, right? I better check because sometimes I make very stupid math mistakes. Like super simple math mistakes that I should not make. We want to check because, well, yeah, negative 8. All right, here's what goes here. Whatever we did right here, we subtracted, goes here. Subtraction. Property of equality. Okay. This extra blank is here because they wanted me to write 9 minus 17 here, and I didn't. So I'm just going to bring down negative 8. Okay. Next. What will we continue to do to solve this equation? Well, we would divide. And get 2. So since we divided, our reason is division. Property of equality. Okay. Okay. Now I'm going to turn it around. Well, let's look up here at our what's going on here. Which one of these just takes it and flips it around? Right here, symmetric property says that if it's 2 equals x, x equals 2 is the same. So symmetric. Property of equality. So all a proof is, and this is technically a proof, these are proofs. All a proof is writing down your explanation for why we do what we do, okay? That's a lot of what geometry is going to be, is explaining what we did, which I know for those of you that loved algebra, is not what you like to do, but geometry is just a bunch of explaining, okay? Once you have this page, we are going to go to the top of 17 and write some vocabulary, okay? So first, a conjecture. And these, again, we make these notebooks so I can say to you, hey, go back to page 17. That's what a conjecture is. A conjecture is a statement that is believed to be true. Doesn't mean it is true. It means you believe that it is true. I'll give you an example one. We're going to highlight the word conjecture. A conjecture is a statement that is believed to be true. For instance, let's say I made the statement, everyone in my 6th period loves math. That might not be true, but I believe it's true, so it's a conjecture. Everyone in my 6th period loves math. That would be my conjecture. Okay? Next, inductive reasoning. Is the process of reasoning that a rule or statement is true because certain cases are true. I'll give an example of that as well. Now, just so you know, I've been teaching geometry. You're my 6th group of geometry students. And you know, I had it myself years ago, but I still get inductive and deductive reasoning confused. So, I try to make it where it makes sense, okay? Inductive reasoning is taking specific cases and making a whole generalization about one person. A lot of people are doing that on Facebook and things right now. For instance, remember how I said my conjecture is every student in my 6th period loves math? Well, if I know for a fact that 2 people in my 6th period love math, inductive reasoning says, well, those 2 people love math, so that means everybody must love math in that class. That's inductive reasoning, taking 2 students and using their love for math as a generalization for everybody in that class to love math, okay? Doesn't mean it's true or not. I'm saying because these cases are true, it's just true for everybody, okay? Next, we have deductive reasoning. Deductive reasoning or deductive reasoning is the process of reasoning using logic to draw conclusions. It's kind of the opposite of inductive reasoning, where I take specific cases and make a whole generalization. It's kind of the opposite of that. For instance, if I knew for a fact that everybody in my 6th period loves math, then out of all, I don't know how many are in there, I think 27, then all 27 of them love math. That means that from the big case, everybody does love it, that means the 1 or 2 students that are over here definitely love it. So inductive is taking small cases and making a big generalization, but deductive is taking a big generalization and applying that to small cases, okay? So taking something big you know is true and applying it to smaller ideas, okay? Last is a counterexample. Last in this set that we're going to list. We still have more notes. A counterexample is an example that shows a conjecture to be false. By the way, you only have to have one counterexample for the whole thing to be wrong. For instance, I said my conjecture is every single student in my 6th period loves math. If there out there is one of you in my 6th period that does not like math, that's a counterexample, and then my statement is wrong. Okay? So that's what a counterexample is. If just one of you in 6th period doesn't like math, then my whole conjecture is wrong. That one person would be my counterexample. Okay? All right, we're going to do a couple of examples of this, of some of these things. There's a bunch of stuff. We are cutting the last piece here from 47. Complete with some zebras, which means your notebook will be decorated with zebras. Isn't that great? Some of you watching this are thinking I'm a little crazy, but that's okay. All right, this is from page 47. You're gluing this in at the bottom of 17. Take a minute, pause it if you need to, so you can cut it out, because I'm going to go ahead and glue it. If you got rid of this the other day when I said don't get rid of this, then you're going to have to write it, so you definitely will have to pause. Just see the whole thing in case you're having to write it down. That's page 47. Okay. Now, I do not understand this. I did not make the book, but these directions only go with 3 and 4. The other directions are actually in the question. I don't know why. Number 3, write each statement as a conditional. Remember, conditional statement is if then. Okay? This says all zebras belong to the genus Equus, and I probably pronounced that wrong, I know. So let's think about that. We need something if, then. Let's think about what our conclusion is. We're going to say our conclusion is they belong to the genus Equus. That means that's going to be at the end. So let's start with if an animal is a zebra, here's our hypothesis, then it belongs to the genus Equus. Here's our conclusion, okay? Pause the video and try number 4 on your own. Something that's nice about number 4 is it only already gives us a if. If it gets 2/3 of the vote in the Senate. That's probably going to be our hypothesis. Now, English lesson, if it, I need to start with if, but I can't say it because you can't use pronouns until you've actually named the noun. So what is it if the bill? If the bill gets, and I'm literally going to copy what this says, 2/3 of the vote in the Senate, then, now I can use it because I've already named the noun, so you can use pronouns now. Then it will pass. Period. If the bill gets 2/3 of the vote in the Senate, hypothesis, then it will pass. Conclusion. That is how you write a conditional statement, an if-then statement. Number 5. Use deductive reasoning to solve the equation. Well, here's what it means. It means we're going to do what we did over here. So I want you to list the steps, and then we're going to explain what happened from step to step. So go ahead and solve this equation out. You do need to have the steps more than you would really need them before because you have to explain what's going on. So the first thing I would do to solve this equation is subtract 3 from both sides, which gives me negative 4x equals negative 8. Why did I do that? Because of the subtraction property of equality. That's why. Okay, now what would I do? I would divide by negative 4. So x equals 2. Why did I divide by negative 4, or why am I allowed to? Because of the division property of equality. Okay, so I'm just explaining what's going on with these. That's all you're doing when it says use deductive reasoning. Number 6 says identify the property of equality that is being used. So you're just going to write down a property of equality. But I need to explain to you where that's happening. So here's what's going on. Here's what you're starting with, and it's going to this. You need to find which property of equality says I can have x equals 2, but then 2x equals 4. And let's think about what's going on in this one. Then I want you to try the others. From x equals 2 to 2x equals 4, that seems like they probably multiplied both sides by 2. So that's the multiplication property of equality. Remember, good idea to do math in pencil. I say as I write in pen. My pens are erasable. Go ahead and try these next 3. So pause the video because I'm going to keep going till the video is short. Try these 3. See if you get them right. I'm going to circle where you're going from here to here. From here to there. From here to there. Find out what happened between them by using one of the properties of equalities that we have on page 16. Okay? So, 5 equals 3a. Therefore, 3a equals 5. It looks like we just swapped them. That is the symmetric property of equality. Okay? The next one. If t equals 4, then 5t plus 7 equals 27. Well, to find that it equals 27, what do you think they did with that t here? They probably plugged it in. Well, which one is plugging it in? I believe that's substitution. Notice I said I believe, like somehow I don't know. Substitution property of equality. Okay. Next, If 9 equals 4x and 4x equals m, well then obviously the first and the last have to be equal. Which one is that one? That's the transitive property. Okay, if you are at home today, what you are doing is taking notes and starting on the homework that's listed for today. Now, that homework is long, and you are doing it today and tomorrow. Tomorrow, whether you are in class or at home, you're still going to be working on that homework. Tomorrow, I'm going to have a Google Meet for the entire class period so that you can ask questions. If you will be here tomorrow, then you are going to need to bring your questions to class because we're going to work the whole time and allowing you to ask questions. This homework's a little different than the others. Some of the others, you have actually been able to type your answers in on Edulastic. Well, your answers on here are going to be paragraphs. And I'm not going to search through and look at those kind of answers. So what you're going to do is you're going to take a picture of all of those pages, okay? And then once you take a picture, just like the problem set, you're going to upload that picture to the homework that's posted, okay? If you have questions, please ask. There will not be a Google Meet today, but there will be one tomorrow. So go ahead and start on the homework that's listed.